This last item is something that not all CB classes covered this term, but there are two types of sequences that we studied, or some of us studied. One of them is a geometric sequence, and the other is an arithmetic sequence. Geometric sequences have a common ratio. All that means is that you're multiplying by the same number again and again to get to new terms. So if I look at this, to find out what the common ratio is, I can calculate that by taking a value, for example, 18, and dividing it by the previous value. And if it's truly a geometric sequence, if I take the next value, 6, and divide it by its previous value, I should get the same value as if I take 2 and divide it by its previous value, divided by 2/3. And if I look at these, it's a little funky, but yeah, 18 over the number 6 is the number 3. 6 over the number 2 is the number 3. 2 over 2/3. Let's see, I did that wrong. 2 over 2 over 3. 2 over 2/3 is the number 3. So the common ratio here, the number that we keep multiplying by to get this sequence is the number 3. And the other thing that we talked about is how can we write the recursive definition of this sequence? Well, the recursive definition looks like this. There's just two parts to it. One of the parts is, where does the sequence start? So we record it by this. The first term has a value of 2/3. So that's me saying where this sequence begins. It begins at the number 2/3. And then I have to record, how do I get to more terms? And this is the notation for it. And I'll say it, but all this means is that the value of the next term in the sequence is equal to the value of the term that you're currently at times the number 3. And that's all this says. These two together are the recursive form, right, of this sequence. And it just says, where do you begin? How do you move forward? We begin at 2/3 and we move forward by multiplying by 3. If I take this calculator and I put the number 2/3 on the stack, enter, and I say times the number 3, you can see my first term there is 2/3. The next term is the number 2, and then 6, and then 18, 54. So every single time I press enter, I'm just dividing or multiplying by another value of 3, and the sequence is just progressing. So all these values I see are numbers that would be part of the sequence. They would be on the sequence. And you can see now I'm in scientific notation. It's become quite large. So this is the recursive form of this geometric sequence. So now let's talk about the recursive form of an arithmetic sequence. Arithmetic sequences don't have a common ratio, they have a common difference. And if I was to take a term like 26 and subtract the previous term, I should get the same thing as if I take the term 14 and subtract its previous term. And I should get the same thing as if I take the number 2 rather, and I subtract its previous term. And if you look at each one of these, right, 26 minus 14, notice I get the number 12. 14 minus 2. Do you need to type that on your calculator? Yes, I'm just demonstrating it. It's 12. And if I take 2 and I subtract the number, watch it, I have to hit this, negative 10. 2 minus negative 10 also is 12. So this has a common difference of 12. And the common difference is what we're always going to expect to see for an arithmetic sequence. Now, the recursive rule for this sequence looks like this. This is the sequence that has a first term. The very first term is the number negative 10. So it begins at negative 10. And to go to the next term in this sequence, you take the value of the term that you're currently at, and you just add 12 to that. And that's all this notation says. When I write this t of n plus 1, all this means is the value of the next term is equal to the value at t of n, the current term, and then plus 12 more. So together, these form the recursive definition of this sequence. And again, it just says we start at negative 10, we add the number 12, we get 2. To get the next one, We're at 2, add 12, we get the next one. We're at 14, add 12, we get the next one. So that's all that this is saying, is you just keep adding 12 to get the next value in the sequence, and it starts at -10.